Exponents challenge problems. So today we're going to look at some harder problems involving exponents. Still the same exponent rules with multiplying, dividing, power properties, power powers, all those rules, negative exponent laws. So we're going to just combine those into some harder problems today and look at some examples. So let's say we have c to the fifth times c to the third all to the negative 2 power, or the c to the third to the negative 2 power. So first thing I'd want to do is apply that power of a power rule, 3 times negative 2. So 3 times negative 2, power of a power, we get c to the negative 6. Now we're multiplying and have the same base, and if I multiply and have the same base, I add the exponent, add the 5 and negative 6 to get c to the negative 1. And then our last step would be to apply the law of negative exponents, 1 over c to the first. So generally when you're told to simplify with exponents, your final answer should not have negative exponents in it. So most of the time you're not going to leave it as c to the negative 1, but 1 over c. All right, let's look at a new example. Say we have 6mn to the third power times 5m to the negative 3 to the second power. So this exponent on the outside, the exponent on the outside applies to each coefficient and each variable on the inside, and this 2 on the outside applies to each coefficient and each variable on the inside. So let's do that. 2 applies to the 5, and the 2 applies to the m. And when I apply the 2 to the m, I have an exponent raised to an exponent. The power of a power rule says that's when we multiply exponents together. This 3 applies to the 6, it applies to the m, it applies to the n. So we get 6 to the third. 1 times 3 is m to the third. And on the n has a 1 on for the exponent. 1 times 3 gives us n to the third as well. And over here we went ahead and simplified this negative 3 times 2 power of a power to get negative 6. So then we can look at multiplying out the 6 to the third. We can multiplying out 5 squared. When we multiply and have the same base with this m to the third and m to the negative 6, if we're multiplying and have the same base, we're going to add those exponents. We're going to get that m to the third. So 5 squared is 25, and then 6 times 6 is 36 times 6 times that is 216. So we get 216. We get the 25. M to the third times m to the negative 6. Multiply and have the same base. We add those together and get m to the third. And, okay, we can bring that forward. So 216 times 25 gives us 5,400. The m's, m to the 6, m to the negative 6 times m to the third gives us m to the third. This n, we know don't have an m term here, so we're going to bring down m to the third, and we have an m to the 6th in the denominator. So now I have an m on the top and an m on the bottom. I have no negative exponents left to deal with, which is great, but this having the same factors on the top and the bottom will cancel out or reduce. Remember when we talked about dividing fractions, we talked about subtracting exponents or canceling common factors. If I think of this as canceling common factors, these m's that are being multiplied on the top 3 times and m being multiplied 6 times on the bottom, the m's will cancel out and we'll end up with 3 extra m's on the bottom. So after we cancel, we'll have m to the third on the bottom, so 5,400 n to the third over m to the third. My final answer, no common factors on the top or the bottom, and no negative exponents. And if I look at the coefficient part, the number part, there's no numbers to reduce here because there's 1 m to the third in the bottom, so no numbers to reduce with that 5,400. All right, let's look at a new one. We have negative 1 in parentheses to the 4th power over negative 5 to the negative 1, all in parentheses to the 2nd power. So this 2 on the outside, it applies to each coefficient and each variable in the numerator. The 2 on the outside applies to each coefficient and each variable in the denominator. We really only have one term here. So we'll have a power of a power rule will give us negative 1 to the 8th power. And when I multiply 2 times negative 1, my exponent raised to an exponent, or power of a power, I get negative 5 to the negative 2 power. Now, what happens when I multiply negative 1 an even amount of times? Well, when I multiply negative an odd amount of times, I get a negative answer. When I multiply negative 1 an even amount of times, I get an even answer. So negative 1 to the 8th power is just going to be 1. This negative 5 to the negative 2 power, before I start multiplying anything out, I want a positive exponent. So I need to bring this base and exponent to the numerator to make it a positive 2. So this negative 1 to the 8th power becomes 1. Negative 5 to the negative 2 power, I'm going to bring that up to make it a positive exponent. So now I have 1 times negative 5 squared. Well, negative 5 is negative 5 times negative 5, which is 25. So I have 1 times 25, or 25. All right, time for you guys to take a shot at one of these. Oh, no, we got one more first. So 5 times 5 to the x minus 3 times 5 to the x. Now, a lot of people will make a mistake on this one because they forget that this 5 has an exponent of 1. So we're multiplying, have the same base, we're going to add the exponent, but if you leave off that 1, you'll get it wrong. So this is going to be 5 to the 1 plus x minus 3 plus x. So we're multiplying, have the same base, we're adding the exponent, you just can't forget about that 1. So then when I combine like terms here in the numerator, x plus x is 2x, and 1 plus a negative 3 is negative 2. So I have 5 to the 2x minus 2. All right, now we get a chance for you guys to try one. You guys try this one. This one's a doozy. Pause the video here, work that out, come back, we'll see how you did. All right, welcome back. So this 5 has to apply to the 10, it applies to the x, it applies to the y. This negative 4 applies to the 2, it applies to the x, it applies to the y. So let's do that. 5 be 10 to the 5th. Power of power, 2 times 5 gives me x to the 10th. Power of power here on the y, negative 2 times 5 gives me y to the negative 10th. The negative 4 applies to the 2, giving me 2 to the negative 4th. The x with 1 times negative 4 gives me x to the negative 4th. And the y, oh, these two negatives cancel out and give me a positive, which is nice. Negative 2 times negative 4 gives me y to the positive 8th. Now that took care of the exponent on the outside, so now I'm going to think of this more of a multiplication problem, like this 10 to the 5th times 2 to the negative 4th. Well, I need to take care of that negative exponent before I multiply. So I'm going to take this 2 to the negative 4th, I'm going to drop it to the denominator, become 2 to the positive 4th. 10 to the 5th is 100,000. X, when I'm multiplying, have the same base x, I can add the exponent. I can add the 10 and negative 4 to get x to the 6. Y is multiplying, have the same base. I can add negative 10 and 8 to get negative 2. So I'm looking pretty good here. The only things I have to deal with now are this negative exponent to make it positive. I'm going to want to bring this y down to make it y squared. And this 2 to the 4th, I'm going to need to multiply out. 2 to the 4th would be 16. 2 times 2 times 2 times 2. The y I brought down to make it a positive exponent. Then I don't have any negative exponents left to deal with. I don't have any common factors to cancel on the variables, no x's or y's to cancel. I do have a common factor to cancel or reduce with this 100,000 and 16. And if I divide 100,000 by 16 or reduce it like a fraction, I would get 6,250 x to the 6 over y squared. All right, you guys can do those. It's just practicing putting all those rules together into a single problem and being consistent with your work. So hope that helps you guys get started on some challenging problems that have to do with exponents. Have a great day. OUT spells out.